Scratching curves. All right, so this curve that we're going to sketch right here is x to the fourth minus 8x to the third plus 18x squared minus 1. And here we have our first derivative. So we're going to do the first derivative test because we're using calculus to sketch this down. And so what we're going to do next is we're going to take this guy and we're going to set him equal to 0, because what we're supposed to do is we're supposed to find out where f prime is undefined or where it equals 0, and that's where you're going to get your critical values. And so because this is it's a polynomial function, I know that there is no x value that I could plug into this that would make f prime undefined, so we don't have to worry about any undefined critical values, but we possibly could find some x values that would make this equal to 0. And so the first thing I'm going to do is I'm going to have to factor this. So to factor this, I'm going to take out a 4x, and this is what I get. And fortunately, I have something that I can easily factor. If we can't easily factor this, then you're going to have to plug this into your calculator and find the zeros using that. It's a cool tool. But when we factor, this is what we get. And then we take each of those factors, we set them equal to 0, and then we get x equals 0 and positive 3. So these are our two critical values. So we're going to take our critical values and make our first line line graph at 0 and 3. And the purpose of that is to find where or which intervals right here where the f prime is positive or negative. Another way to say that is where f is increasing or decreasing, because knowing if f prime is positive or negative, we know if f is increasing or decreasing. So one way to do that is to plug in some numbers. So we're going to plug in -1, we're going to plug in 1, and also we're going to plug in 4. So we plug those numbers into our f prime. So I'm going to plug in -1, I'm going to plug in +1, and I'm going to plug in 4 to f prime. And so this one's not that bad. Like when I could take 0 and plug this in pretty simply and find out what my answer is. And our answer is actually 0 right there. I'm sorry, not 0. We could take -1, we could plug this in, and we can find out if we get a positive or negative number. But we don't have to find the exact number, okay? Keep that in mind. We don't have to find the exact number. So if I plug in -1, I know that this third power is going to keep it negative, and so that's going to be a -4. And then over here, that's going to make that's going to be a positive, so that's going to be a -24. And then if I plug a -1 into that, it's going to be a -36. That is clearly going to be a negative number. So in this interval, this first interval right here, we know that we're negative. Now I'm going to plug in a +1 to see what we get. Let's do that in our head as well. If I plug in a +1 right there, that's going to be a +4. And then we're going to subtract a 24. And then if I plug in a 1 right here, that'll be a +36. This will be definitely a positive because there's definitely more positives there. So in this interval, we're going to have a positive. And then finally for the last one, we're going to plug in our 4 and see what happens. If I plug in 4 to this, that's going to be a 64 times 4. That's a really big positive number. So I'm just going to put, I wouldn't write this, but big positive. Usually I wouldn't write that. And then we have a minus 24 times 16. So that's going to be a big negative, but it's definitely not going to be a bigger negative than this positive. I mean, because this big positive, I probably should have written it. This big positive is going to be 64 times 4. I'm pretty sure that this is more than that. I don't know. Maybe it's too close to call. Maybe I should try it. And then we're going to add a 36 times 4. Now I'm pretty dang confident. Okay, so we got all of these positives and all these positives and just these negatives. So I'm pretty sure that our answer is going to end up being a positive. If you're not confident in that, find those numbers and see if you get a positive or negative. But I'm pretty confident it's going to be a positive. And that's the end of our first derivative test. Now I know which intervals we're increasing and decreasing for f. The other thing we need to know is the curvature of the line, or the concavity. So we're going to do the second derivative test. To do the second derivative test, I need the second derivative. So I'm going to take the second derivative of f prime by taking the derivative of f by taking the derivative of f prime. So we're going to get 12x to the second power minus 48x plus 36. It looks like we can factor out a 12 right here and make our lives a little nicer. That's going to be a -4, and then that's a 3. Yay. And this is definitely, is that factorable? Yeah, that's factorable. So it's x minus 3, x minus 1, and don't forget your 12 out in front. This is f double prime I'm going to take this f double prime, and I'm going to set this equal to 0 to find possible inflection points. Now, that wasn't true over here. Over here, we were finding critical values. I didn't say possible critical values. I said critical values. These are critical values, hands down. It can't be anything else. But these are possible inflection points. It looks like this is a polynomial function, so I don't need to worry about it being undefined anywhere. I just need to find out where it equals 0. So I'm going to find where it equals 0 by setting each of these factors equal to 0, and I get 3 and 1. And so when I do my sign line graph for f double prime, I'm going to put a 1 right here and an f and a 3 right here. And I forgot to do that for my other one. I like to write on the side like what I'm doing it for. That way I know what numbers I'm going to, or where I'm going to plug the numbers in to test to see if we get positive or negative there. So this number I'm going to test, I don't want green or orange, and I'm going to also test a 2, and let's test a 4. It doesn't matter what number you pick in that interval. I just try to pick small numbers. So if I plug 0 into f prime, that would look something like this. We go f prime, we plug 0 into it. What would we get? See, that would be 0, that would be 0, and I would be left with positive 36. That was too easy. So we get a positive for that first interval. That means we're concaving up in that first interval. Then I'm going to take the 2 and plug that down again. If I plug 2 into this, that would be 2 squared to be 4. 4 times 12 is going to be 48. The next number is going to be 48 times 2, so that's going to be 96. And then the last one is just 36. So I'm not sure. That's kind of close to call, I guess. I don't know. If you're a math whiz, you probably figured it out already. See, how many positives do I have? If I add 6 to 48, that's going to be 54 plus a 3, so it's going to be 84. 84 minus 96, that's definitely going to be a negative. So I'm going to put a negative right there, and now I'm going to try the 4. Plug in 4. Let's see what we get. So there I go. I plugged into 4, and I got 16 times 12. I got 192, and when I go 48 times 4, I get 192, but that one's negative, so these kind of cancel each other out, and I'm left with positive 36. So we have a positive. So it looks like 1 and 3 are both inflection points. And the reason why they're inflection points is because the sign changes over 1 and the sign changes over 3. So next what I want to do is I want to make a double sign line graph. And so I'm going to draw a little x-axis right here. And I'm going to put 0 first. Get that from over here, this critical point. And then the next one will be 1. And then 3. 3 is actually on both my second derivative and my first derivative. And so let's put my signs on each of these. So let's go first in our interval before 0. Before 0, our first sign is going to be negative. So that means we're decreasing on our curve. And then you can help. Just tell me, okay, Charlie, do you know what that is right there? That's a plus sign. Can you say positive?
I want to draw.
You want to draw? Well, I'm going to draw right now. So we got a positive for the second derivative. That means we're decreasing and we're concaving up. And then after the 0, between the 0 and the 1, after the 0, the first sign changes. Oops, I wanted to make this one blue. So the first sign changes to a positive, and it looks like we're still positive for the inflection point, or not inflection point, for concavity until we pass 1. Once we pass 1, we're still positive for the first sign, but after 1 goes by, we do get a negative for our concavity, so that changes to negative. And then,
I want to draw.
Okay, you can draw the next one. Okay, hold on. Then 3 happens. Now, when 3 happens, our first derivative says we're increasing, and our second derivative says that we're concaving up. So, Charlie, you want to draw the signs? Okay, that's a nice plus sign. Now we're going to switch to blue. Now you draw the plus sign for the blue. Good job. So that one says plus plus. Now we can sketch our curve. Charlie, connect the dots for that x-axis. Oh, wow, that's pretty good. Good job. Okay, so when I draw my curve, I put my x numbers on here. That's where things change. That's where the signs change. That's okay. Oh, I'll erase that. Okay, hold on. Now, it doesn't matter where you start before the 0. Okay, we're just starting over in this area. That is this area. That's those signs. We're decreasing and concaving up. So doesn't matter where you start, just as long as we draw a line that is decreasing and concaving up. You want to draw the next one? Okay, hold on. The next one is increasing and concaving up still. So we're just going to go ahead and wrap this around. Charlie, I want you to draw a line that looks like that, okay?
Okay.
Go. Oh, so good, so good. Actually, it needs to curve a little bit more. That one's too straight. All right, connect those dots. No, try again. Lift your finger up. Go ahead. Oh, very good. You're a good dot connector. All right, so we're increasing and concaving up. And then this one right here, it says that we're increasing still, but then we start to concave down. So Charlie, here, go ahead and connect these dots. Go. Go. We'll try it again. Let's count. Give me your finger. There you go. What'd you say?
I'll do the down one.
You want to do the down one? But look, we're still increasing, so it's still positive. So we're still going to keep increasing, but then we change to concave up. So that means we're going to go like this. All right, so there's our curve. We have a point of inflection right there, because that's where the concavity changes. Oh, and the concavity changes right there. Oh, and here's where our critical values are, right there, and I think we got one right there too. Yeah.
That looks like our car.
That's how you curve sketch using calculus.